Hey there, Joe Braun here, the DCS Mech Warriors. In this video, we are going to run a DC motor to a specific position. So let me go ahead and switch over to my desktop and we'll get started. All right, so in the previous video, we were setting a DC motor to a joystick and the one before that to buttons. Now we're going to use buttons, but we're going to run it to a specific position instead of just turning it on. So let me go ahead and open up Team Code and Java. And then we're going to make a copy of our previous one, which was motor 2. So I'm going to right click on that and copy. Come up here and right click on YouTube and click paste. And then we're going to call this one motor 3. So I'm going to replace 2 with a 3. Oh, I pushed caps lock, it looks like. So let me undo that. There we go, and push enter. All right, and then just as in previous videos, I'm going to open up my notes here. So we're running to position, and I'm going to move that down to the bottom of the screen so you can see my notes and what we're working on at the same time. And let me go ahead and close this side menu. Okay, so this one is going to be a little more elaborate than the previous one, a little more setup, and then a little bit more functionality that we can add to this. So let me go ahead and begin by changing our configuration file, just as we have done in other videos. So motor port, in this case, would be 2. And we're going to call this motor 3. And so our configuration is configuration file notes are set up. We still have to go into the driver hub and add that in there. Our disabled and group is going to be the same. Our class is the same. We're going to keep all of our previous variables that we did in the previous videos. So we're going to create some space here to drop in our new variables for motor 3. So let me copy that and drop those in. So just as in the other videos, DC motor is the class that we're calling, and we're calling this motor 3 for our variable. We're setting 0 power to 0, and we're setting our overall power to 1. Of course, if you were doing this for a robot, you could set that to something else besides 1, but we're setting it to 1. And then just as we said in the opener, we're running this to position. We're going to actually alternate between 2 positions. So the first position on the encoder is 0, and the second position is 1000. Now you could easily make this negative 1000 or 5000 or whatever you wanted it to run it to. But when it inits, it's going to set that to 0, and then these 2 positions can be anything that you want. So let me go ahead and drop down to our override function that we're run op mode that we're overriding from the parent class. This all remains the same. Our method calls, as in previous videos, are still the same. So we haven't made any changes there. And then we're going to go down to init hardware. And then here's where we're going to add in our third motor. So we're going to init motor 4. Actually 3 is what this one is. And then add our parentheses to indicate that it's a function, and then our semicolon. Now this is still red because we haven't created that function, so that's the next thing that we need to do. So we're going to drop down, and this one has some changes. I probably still, if I was creating this, would go ahead and copy the previous one and then make the changes that we have in our notes to this one. So 3 would be our method call. And so now that is no longer red. This one's no longer red. And then this changed from gray to kind of the gold color there because it's now able to find that function and call it up here. Okay, so just again, in case maybe this is the first video you've watched in the series, we have created a function for our setup. That function is being called in our init hardware. So we have a method stack here of all of our hardware. Nice, clean place to see what hardware is actually being coded here. And then this function is being called in our general run op mode up here. When we push init, it's the very first thing that it's going to run. So keeping everything zoomed out in this top level, and then we kind of layer things in so that it's easy to figure out what's going on. At least that's the way we think of it. So what we want to do is now go into this init hardware for motor 3 and go ahead and make our changes for the setup. So I'm going to scroll down here just to make sure I don't miss anything. But the easy part is we're going to change this to a 3 because we're not doing motor 2. So now we have the variable. I'm going to change all of these variables now to motor 3. So I'm just double clicking and then pushing Control V for paste. I'm also going to change my config file name for our hardware map to motor 3. So now when we do it correctly, we enter it into the driver hub. It now knows how to make that connection, how to make that logical connection for each one of these motors. So this one is now set up right. And we're still running a DC motor class, so we don't need to make any changes there. In this one, we're going to run it as forward. So I'm going to change this to forward. So FOR and then tab, and it'll fill it in for me. Our zero power is going to be 3. And so zero power, motor 3 zero power. Let me go ahead and delete that. That was kind of an accident. We are going to change this one to brake because we want to stop as fast as possible on that location. So brake and then tab. And then we still want to, when we init the motor, we still want it to clear out any encoder data that it might have and set that exact position as 0. So when you init the robot, you need to make sure that that's the spot that you want it to think is 0. And that's already set up for us. And then we're going to, in this case, set it up to run using encoder, at least in the beginning steps. We're going to change this to run to position a little bit later, but when we run our init, it's going to be set to run using encoder just out of the get-go. So what we're going to do now is drop down to the Teleop controls. And actually, before we do that, we probably should go ahead and do this function so that it makes more sense. Back up here, what we're going to do is call this particular function and set its position. But it's going to be all red when we set up our Teleop controls. So let's go ahead and make the function itself down below Teleop controls. So I'm going to drop down here, put a couple enters, and we're going to create this function. And I'm going to go ahead and copy it just to save time. You don't need to watch me type very slowly. So let me go ahead and paste that in. And now let's go ahead and explain it. So we've created a function, public void. It's not going to send any information back. We're running motor 3 to a position, so very descriptive method name. We've got some parameters. We got a method with a parameter inside it. Basically, that's a local variable that's being defined for the method call, and when you call it, you'll put in a number. We'll show you that in a second. But we're basically going to feed this method a number out of the get-go. In this case, it's going to be an integer that's going to tell it what position to run to. So end our parenthesis and then our code block of what to run if this method is called. So what we're going to do is set up for motor 3 a target position, and that position is going to be fed again and used right here. So we're passing this method a number, and that number is going to be here for the target position. We'll show you how that works here in a second. We're going to set the mode now to run to position instead of run using encoder, so it's going to change the mode. And then it's going to set the power that we want to run to this motor 3 power, which is 100%. Let me hold down control and click on it. We'll jump right back up there, and there's motor 3 power. So let me drop back down. And then what it's going to do after these 3 settings, it is going to start to move the motor. So while that motor 3 is busy, so this again is a true function, it's going to do it over and over and over again. So it's in a while loop while this is true. It's basically going to do nothing. So what you could do is leave this empty so that it's not moving any further in the code. It's just waiting for that motor to not be busy. But as an additional feature, I'm going to push Control Z here a few times. We're going to output the data, the telemetry data to the driver hub so that we can use this as a troubleshooting feature. So maybe the motor, when we ran it, we want to run in the opposite direction. So we wouldn't know that unless we had the telemetry data on the driver hub that it's running in the wrong direction. It might be running forever because it can't find that location. So we might need to come in here and push reverse depending on your robot. So we want to have that telemetry data so we can use it for troubleshooting. So once it's done, once it's finished being busy, in other words, finished moving, it's going to move out of this loop and then on to the next step. So once it's to the position, we're going to set the motor power to 0. Now, as a caveat here, maybe you don't want to do this step. maybe your DC motor is lifting something up, and once it gets to that position, you want it to hold that position, and not, if it goes to 0 power, it's just going to turn the motor power to 0, and the motor is going to fall due to gravity. So you may or may not want this step, depending on what you're doing with your robot. So I guess we could put this one as an optional step, because you may not want it to go to 0. You may want it to just hold that position, because it's running to a position. The PID controller in the background is going to hold it at that position. So if it starts to move away from that position, it's going to give it enough power to go back to it. So I've seen a lot of teams, they'll try to put just enough power on a motor. They're running it, say, to encoder instead of to position, and then try to hold a position with some random power. And that's not the best way to do it. To use this run to position is the best way to hold a motor at a position. So this is what I would suggest. Again, you may not want this step here, because if it's underweight, then it will fall. Okay, so moving on then, we're going to go back up to our Teleop controls, and now we're going to use this function. It's grayed out because it's not been used. So we've got motor 1 here and motor 2. So we're going to make some space after the end here and put in motor 3. So the functionality that we're going to add first are these two functions, not functions, these two steps, these two, well, they're actually conditional statements. This is an if statement and this is an if statement. So if this is true, run this code. Well, what is this true? Well, on gamepad 2, we've pressed the left bumper. So if that's true, it's going to run motor 3 to position. So it's going to call this function down here, and we're going to pass it a number. Well, we're not hard coding the number here again. We want to have those numbers up top in our global variables. We never want to hard code numbers further down, because if we change them on one spot, it doesn't necessarily change them in all others. So again, we've discussed that in previous videos. So we want to have a variable here instead of a number. So if I control click on this, position 1, it's going to basically do nothing, because when we started the init, it was at 0 already. So in this particular instance, when we press the left bumper, it's going to run to position 0, which is where it already is, but it will hold that position because we are running it to position. And let me drop back down here. We said this is optional, so say it was underweight, we would want to go ahead and comment that out, and now it will hold position at 0. So the motor is actually holding it at 0. So now, if we press the right bumper, so this statement is true, okay, on the gamepad 2, it's going to run the motor to position, and this position is position 2. Well, what is position 2? It's set at 1,000. If I wanted to change it, I would change it right there. So it's going to run to 1,000 on the encoder, trying to find it here, if we push bumper 2. So I can push the left bumper, it'll go back to 0. I can push the right bumper, it'll go to 1,000. So I can get it to oscillate between two positions using a DC motor. So there's a lot more torque behind that, or a lot more speed than a servo would have. So you could use a DC motor to run between two positions. And we do this a lot with our lift systems. So if we're wanting to lift something to a certain height and then go back down to 0, we'll use a function, something similar to this to make that happen, similar to this function down here. So the other thing that we might want to happen is if we're doing tests, especially when we're first setting this up, we might want to reset an encoder back to 0 or to some other number. It doesn't have to be 0. It could be some other number. So what we're going to do is add some functionality to reset our encoder. To do that, what we're going to do is come down here and create a few more functions. So we're going to have a reset encoder function. We're going to have a stop motor, a reset motor, and a reset mode. Again, this is a little bit overkill because we're creating an individual function for just one line of code. But say we were wanting to do this on a drivetrain. So we had 4 motors. We would want to reset all those at the same time. So we'd want to stop the motors, stop and reset the encoder, and reset the mode. And we'd want to do that on 4 different motors all at the same time. Well, we can put all of those lines of code in the same function and then call the big picture. And then when we push the button up here in Teleop controls, it will go right here, then that will execute on all 4 motors at the same time. So we're going to build this as if we had more than one piece of hardware for this particular example. So underneath here, what we're going to do is add those functions. So the first one we'll add is a public void. Let's do our stop motor first. And I have motors, even though it's only one motor in this instance. And go ahead and do our code block. So if I was doing this in a classroom, again, what I'd encourage the students to do is to copy that and then paste it a couple times. So we've got stop motor, and it's red again because we pasted it in. So we want to have a reset mode. And then we also want to have, oh, that was supposed to go here. And then we want to have a, oh, no, I was in the right spot. I just looked at the wrong one. So reset mode is last. And this one would be stop and reset encoder. So let me put that in here. Stop and no space. So reset encoder. And we'll put an S there to be consistent. So reset mode, that would be the same for all of them. So we'll leave that as is. Okay, so we've got our 3 functions. And then that function is going to be called by a method stack. So I thought I had the function copied here. So let me copy that again and paste that in. And then this one is calling our reset encoders. So this is our overall method stack. So reset encoders will go up here. So that's going to call each one of these methods down below. So we can go ahead and put those in. I'm going to actually backspace and push enter so it ends up in the right spot. So stop and stop motors would be the correct one. And then we're going to stop and, so tab. And then the next one was reset mode. So reset and then tab. So now we've got our 3 functions that we're going to call. We could put several motors inside there. We've got our method stack, and that method stack is eventually going to be called up here in Teleop controls. When we set that up to be activated by a button, we'll do that here in a second. So now what goes in each one of these? Well, this again is the shorthand notation because there's only one in there. I am just going to copy and paste these in. So wrong spot there. Let me do that in the right spot. So motor 3, we're going to set the power to 0 power. So we're stopping the motor. And then just like in the init mode, we're going to want this one actually, stop and reset the encoder. So I'm going to copy this line and put that in there. And then reset the mode. We're going to reset the mode back to what we did during init, is to run using encoder. So we're going to change that mode back to there. Now the only thing we haven't done is use the function itself. So we're going to come back up here to Teleop controls. And right here underneath where we use the motor itself, we're going to add a reset the encoder. Now you could do this on all 3 motors if you wanted. So motor 1, motor 2, and motor 3 that we've done in previous videos. But we're just going to do it on this particular one. So copy and paste. And again, we're setting this one to Y. So in previous videos, we used X, A, and B. So Y is unused. So button Y, if we push that on the gamepad 2, if this is true, we're going to run the reset encoder function. Well, that's going to come down here and run all 3 of these methods, which is going to run all 3 of these down here. Again, a whole lot of overkill there. You could easily put these 3 lines of code inside just this function. Again, this is the way we would set it up if we had more than one motor instead of just one like we have in this example. Okay, hopefully that makes sense. The last thing that we want to do is change our encoder or our telemetry data down here that we're receiving from our encoders. So these 2, we're going to say, hey, we're done with these. So we're going to comment those out instead of delete them. Push and enter, and then come down and grab a couple lines. Actually, this first line is new. So this is just a simple comment that we're saying note. Tap Y to reset the encoder so that the functionality is there for the user. They know what to push. And then motor 3, the encoder data and power is being gathered using the get function on those motors to output the data all in one line, and we covered that in a previous video. So I think we're good there. This is the new piece, just to put a message on the driver hub. That's what that would look like. And so let me just double check, make sure I didn't miss anything in this particular video. And it looks like I think we are good. So I actually don't remember, I haven't looked at my notes on what the next video is. So let's check that out real quick. New member training, we're going to be going into a max velocity test. So these two kind of go hand in hand. A max velocity test is going to tell us what the maximum velocity is of a motor, kind of intuitive there. But then we're going to use that data to manually tune a PID rather than letting the generic PID for FTC run it in the background. We're going to set the numbers ourselves. And so those are what the next two videos are going to be. We have to figure out the max velocity of the motor and then use that to tune the PID. So if you're interested in that, stay tuned in the series, and hope you enjoyed this one. Any comments, put those down below, obviously, and hope we catch you in the next video. Catch you later. Bye-bye.